Unable to control your food cravings and having difficulty maintaining a healthy, balanced diet? Want to learn some neuroscience secrets? Keep listening on to find out, only here on the People Scientist podcast.
Listening to The People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on neuroscience, physiology, and nutrition. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking, to help us be one step closer to the healthiest we can be.
Hello, my People Scientist Army, and welcome back to the People Scientist podcast for episode 59, where every week I arm us with some scientific evidence so we can all lead the healthy lives we want to live. How are we all doing this week? I understand some places are lifting the lockdown and some are slowly starting to go back to work in some parts of the world. How are you all feeling about that? Now, here in New York, we are still in lockdown until May 15th. At that point, Governor Cuomo is going to reevaluate and see if we need to extend the lockdown or if we can start lifting certain restrictions for the non-essential staff. But until then, you can know that I will be a constant for you, as I will continue to post an episode every Sunday morning on topics that have an impact on our health. Last week's episode was very popular, in that I combined nutrition with neuroscience and mental health on relevant topics of our quarantine eating habits, such as consuming more caffeine, consuming more alcohol, and less nutrients than usual, which all of these have the potential for a large impact on our brain and mental health. I would love to hear what your thoughts were on the episode. I was asked to cover for today the neuroscience of food craving and what we can do to help ourselves control our food cravings. Now, this is a topic that I'm really passionate about. I'm currently studying in my lab right now. So let's dive down the science rabbit hole together and start off with some core takeaways. Food craving is one of the biggest obstacles to us keeping on track and leading a very healthy life. This is also one of the reasons I actually transitioned from nutrition and physiology to behavioral neuroscience, so I can understand how our brain impacts our behavior and vice versa. And I want to share with you what I have learned. Many people can give you suggestions to combat food cravings, but the real secret ingredient is understanding our own brain and why we feel the way we do. Knowing why is far more powerful than knowing the what, because you can understand yourself better by knowing the why. For example, that has that famous saying goes, give a person a fish they can eat for a day. But if you teach a person to fish, then they can eat for a lifetime. What I'm giving you is a neuroscience framework to build upon so you can create strategies for yourself. In today's episode, I talk about the brain regions that are involved in food craving and food addiction. This in itself is very powerful to know, because that information on which brain regions are involved gives us something to target in order to generate new strategies so that we can hopefully gain power over our food cravings. Understanding our own brain and how it works will, so to speak, put the steering wheel in our hands and lets us decide which direction we want to go in. Now, we'll talk about in today's episode 2 particular pathways in our brain involved in food addiction and how we can use healthy strategies to recruit these brain regions instead of turning to unhealthy food. For example, I talk about our brain and exercise, music, social interaction, heat therapy, apple cider vinegar, cruciferous vegetables, bitter tastings, distension of our stomach, and much more. This is a big episode, so how about we jump into those details? Let's start off by defining food craving. When we crave food, It means that at the time, we do not feel satiated or satisfied. We feel like we miss and want the pleasure and rewarding response we typically get from eating delicious food. Food cravings can also include intrusive thoughts about eating or drinking. For example, we could be busy working, watching TV, talking on the phone, and these thoughts of snacking come into our mind. These thoughts can be overwhelming at times and can impact our actions by making us go to grab the snacks and lead us to eat too much of some unhealthy items, even though we really don't want to eat them. This is one of the biggest obstacles to us keeping on track and leading a healthy lifestyle. Food craving can be the result of basic hunger and reducing the aversive feeling of hunger. This is an innate survival physiological response. But what is more complex to food craving is the involvement of food addiction and stress. Now, many similarities have been drawn between drug addiction and food addiction, as things like sugar and fat are able to recruit the same brain regions that addictive drugs do in order to generate that pleasurable, feel-good response. And cravings are not specific to food. People may also crave other addictive things like cigarettes. So a lot of what I will say about food cravings may also hold some similarities to drug addiction as well, as high-fat, high-sugar food and addictive drugs have some similarities in their neurobiological mechanisms, meaning that they impact our brain in similar ways. And my mentor, Dr. Paul Kenny, has published on this concept of drug addiction being similar to food addiction in regard to the neurobiological mechanisms. Now, food cravings are a big reason why many of us regain weight after restricting ourselves or after dieting, the so-called yo-yo dieting. Food cravings may be why many of us can't seem to gain control and eat a healthy diet consistently. So why does this happen to us? And how can we use neuroscience to help us regain control over our eating patterns? Well, this topic is very complex, and many scientists have spent their lives researching the details of this. Stress systems and emotional responses are certainly involved in food cravings, meaning when we feel stressed or anxious, we are more likely to relapse and to try to self-medicate ourselves and make ourselves feel better by turning to delicious food, because delicious food makes us feel better. Other systems, though, are involved, such as our gut microbiome or the bacteria and yeast living in our gastrointestinal tract. They can play a role in food cravings as well. But for today, I'm going to streamline it and try to focus on just a couple of things. And so today I'm going to focus on two brain regions or pathways. The first brain pathway that I've actually spoken at length about before in episode 46 is the brain reward pathway. Now, some brain regions included in this pathway include the striatum, the nucleus accumbens, and the ventral tegmental area. These brain regions modulate a lot more than reward and pleasure, but they have been generalized as being part of that brain reward pathway. The reason why is because these brain regions are known to regulate the pleasure and feel-good response and reinforcing characteristics of delicious food that is rich in sugar and fat. These brain regions are implicated in addiction. Because these brain regions control the feel-good, pleasurable response, these brain regions are responsible for reinforcing the habit of us wanting to obtain whatever it is that made us feel good. So for example, when we eat an Oreo cookie, those brain regions are very likely activated. When we want an Oreo cookie and we are trying to restrict ourselves and avoid it, these brain regions may exhibit lower activity than normal, which could potentially lead to a feeling of low mood or temporary depression and anxiety. Now, I covered this topic in last week's episode in regard to caffeine withdrawal. Caffeine, too, can activate this brain reward region, which can elicit that feel-good response and makes caffeine or coffee reinforcing. But if someone goes into caffeine withdrawal, periods of low mood are possible because these brain regions that normally give us a feel-good response are now not getting activated as much. So our brain wants to avoid those negative feelings. Our brain wants our brain reward pathway to be stimulated, hence a craving response. Okay, now that we understand that brain reward pathway and how it plays a role in the feel-good, pleasurable response in eating junk food, let's talk about the other brain region for today. And this brain region is what makes the concept of food craving really interesting to me because it regulates the state of satiety. And that brain region is called the Nucleus of the Tractus Solitarius, or the NTS. So satiety means that we feel satiated. We're not craving. We feel content or full. Now, this is a very important state to reach during drug addiction or with food addiction, because it is the state to which we feel we are satisfied, don't need more. And the NTS regulates this. The next stage after satiety, if we take in too much, is aversion, meaning a negative feeling, for example, like nausea. This brain region also regulates that. So, for example, we may eat 2 Oreos and feel good and satisfied, but if we push it and eat 20 Oreos, we may have some aversive negative feelings, like nausea. Or, for example, if we smoke 1 cigarette and feel fine and satisfied, but if we smoke 10 cigarettes, we may feel sick. That is the sliding scale of satiety to aversion. This was illustrated by the lab I am a part of in the journal Nature Neuroscience in 2017 by the first author, Louis Tuesta. Now, when they activated specifically the glucagon-like peptide 1 neurons of the NTS of the brain, it reduced nicotine-taking behavior. It reduced the motivation to obtain nicotine. So the authors called these the satiety sensors of the brain, so to speak. Similarly, Wang in the journal Cell Reports in 2015 illustrated that these same satiety sensing neurons of the brain also regulate food intake. When these neurons are activated, the intake and motivation to obtain high sugar, high fat food in mice was dramatically reduced. Now, this is really key because these neurons hold the secret to regulating our cravings, to inducing our satiety. So before I move on to the strategies for us to help regulate our cravings, I want to simply summarize the neuroscience I just shared. Now, this will be a bit of an overgeneralization, especially to the neuroscientists that are listening, but this generalization will help us understand why we may feel the way we do sometimes. So when we eat high sugar, high fat food, we know a couple of brain regions that are involved. The first is the brain reward pathway. That brain reward pathway makes us feel good and have that pleasurable response when we eat the junk food. The other brain region is the NTS. This brain region makes us feel satisfied, no longer crave food in the moment. Understanding that in itself, those brain regions that are involved and why they're involved, gives us a lot of power because now we have targets for our healthy strategies. Because if we can activate these same neurons in a healthy manner, we have found a good replacement for the unhealthy junk food, and essentially a way to reduce or control our cravings. So that is the next part of this episode, is to find healthy strategies that can target these exact same brain regions that junk food does. The first strategy is we can do activities that activate this brain reward pathway in a healthy way. So for example, if we want to eat that Oreo cookie and choose not to, we're trying to avoid it, this brain region, the brain reward pathway, is no longer being activated to the same extent. It's no longer giving us the same pleasurable response, and this can lead to potentially a low mood or a feeling of depression. So let's activate this brain region and get our pleasurable response from healthy things instead. For example, we know from hundreds of studies that exercise or getting our body moving in some manner can recruit the brain reward pathway and actually makes this pathway more sensitive by increasing the number of dopamine receptors. And I talk about this at length in episode 46. For example, Robertson in the journal Neuropsychopharmacology in 2016 illustrated that an 8-week exercise regimen that consisted of 1 hour of exercise 3 times a week significantly improved dopamine sensitivity in the brain reward pathway as measured by PET scans in those with methamphetamine addiction versus those that were just receiving a health education class. So exercise had a great beneficial impact on the brain reward pathway in this particular clinical trial. Cicelli in 2018 in the journal Movement Disorders investigated the activity of the brain reward pathway and dopamine sensitivity using PET and fMRI scans in habitual exercisers versus sedentary or non-exercising individuals living with Parkinson's disease. The scientists noted that in those individuals who exercised regularly, they had stronger dopamine signals, greater activity of the brain reward pathway, and lower apathy scores, meaning those who exercised were more motivated and had more enthusiasm than the sedentary, non-exercising individuals. So these clinical trials taken together illustrate that physical activity can enhance the brain reward pathway, dopamine signaling, and enhanced measures of mood and motivation. So if you needed any more reason to get your body moving, there it is. But what other strategies can we use to fight food cravings by activating our brain reward pathway? Well, music can activate this brain region. Salampour in 2011 published that the anticipation of someone's favorite music elicited dopamine release in one part of the brain reward pathway, and listening to the peak of their desired song elicited a stronger dopamine release in the other different part of the brain reward pathway. So music may also be a great strategy. I talked about heat therapy just a few weeks back in episode 55. For example, a hot shower, a hot bath, hot yoga, or sauna use. All of these heat therapies have the potential to recruit the brain reward pathway as well, and actually can have a secondary effect in that they can help reduce the activity of a stress circuit in our brain called the HPA axis, as heat therapy can act upon heat shock proteins to teach the HPA axis to learn to inhibit itself, thereby reducing levels of stress. So if you want the details on that, I encourage you to go back and give that one a listen. As I mentioned earlier in the episode, stress may be more likely to cause us to relapse and go to those unhealthy reinforcing behaviors of eating junk food. So if we can find healthy strategies to help us cope with our stress, then it may be able to help us remain on a healthier diet. Social interaction, or interacting with people in a positive way, may also recruit the same brain region. In Nature in 2013, Dolan and others showed how social reward, or the rewarding feelings of socializing with others, involves the nucleus accumbens, a brain region that is in the brain reward pathway. So during times of food craving, these are just some examples of healthy things that we can turn to in order to recruit the same brain region that would normally be recruited when we eat delicious, unhealthy food. This could help us deal with the low dopaminergic state we may be in when we restrict ourselves from the junk food. Now that we know what brain region is involved, if any new treatments come out to which they recruit this same brain region, that means that they can potentially help us in our food cravings. It gives us an area to further investigate. Next, let's talk about strategies to recruit that other brain region I talked about, the NTS. Now remember, certain neurons in the NTS are involved in the satiety response, us feeling satiated and us feeling like we don't have cravings anymore. So from my nutritionist and neuroscientist perspective, it makes sense to me to find a healthy way to activate these satiety sensing neurons to make us feel satiated. But that thing itself either has to be healthy or not addictive. What that means is the strategy has to activate these neurons in the brain regions, but not activate the brain reward pathway. Because, for example, we know that nicotine in cigarettes activates the NTS, and specifically those glucagon-like peptide 1 neurons in the NTS, to induce that satiety response. That is in part why we think nicotine in cigarettes can reduce one's appetite and craving for food, because nicotine acts on those same satiety sensing neurons. But we don't want to replace one addiction for another. We don't want to start smoking cigarettes so we don't eat junk food, because that is not healthy. So the neuroscience key is to find something that activates these satiety neurons, but does not activate our brain reward pathway, so that it's not addictive. Meaning that we need something that induces the satiety signal without the pleasurable signal. So what could that be? In Nature in 2006, some scientists detailed a very interesting study, how our different senses of taste can indicate different things. So we have 5 tastes. We have sweet, bitter, sour, salty, and the newest one, umami, which indicates the presence of protein or the amino acid glutamate. Now, sweet and umami tastes are thought to detect nutritious substances like carbohydrates and protein. Bitter and sour tastes are thought to potentially detect toxic substances and therefore signal for us to prevent ingesting those. Whereas the salty taste provides the detection of certain electrolytes, which we also need for survival. Now, interestingly, Scott and colleagues in 1986 in monkeys had illustrated that specifically a bitter taste and a sour taste had very similar patterns of activity in the NTS satiety brain region, meaning that these two tastes, sour and bitter, have a lot of similarity in how they impact this brain region, which is distinctly different from how sweet, salt, and umami tastes impact this brain region. Now, this makes sense to me as both sour and bitter tastes indicate that we could be consuming something potentially harmful, because sour and bitter tastes seem to be associated with potentially poisonous things found in the environment. And that was the case centuries ago, but now in today's food supply, bitter and sour things are not harmful. And instead, we might actually be able to use bitter and sour foods and beverages to our benefit. Now, this is the fascinating neuroscience key. Bitter and sour taste in the absence of sweet, salty, or umami taste can activate the NTS in a similar manner, which is really fascinating. Now, I've touched upon bitter taste as a way to induce satiety back in episode 45. Strong coffee, for example, contains many bitter compounds. However, if you recall, as I spoke about last week on the podcast, caffeine, which is present in coffee, can stimulate the brain reward pathway, meaning that it can be reinforcing and potentially addicting. So maybe we don't want to develop a caffeine addiction by drinking more coffee. But decaffeinated coffee has actually proven effective in reducing food craving and increasing the release of satiety hormones in the body. For example, Greenberg in 2012, in the Journal of the American College of Nutrition, conducted a randomized blinded controlled study in 11 men to examine the appetite-reducing effects of 4 drinks, either water alone, caffeine in water, regular caffeinated coffee, or decaffeinated coffee. Now, 1 hour after drinking the beverage, the participants drank a sugary drink. The scientists measured gut hormones in their blood that regulate appetite, satiety, and food craving. They also assessed their feelings of hunger and food craving. Interestingly, decaffeinated coffee had the strongest effect on reducing feelings of hunger and increasing blood levels of the gut hormone peptide YY that can reduce appetite and increase feelings of satiety and satiation. Coffee was the second best, that was coffee with caffeine, was the second best in reducing hunger, and caffeine in water was the least effective next to water alone. This study suggests that the compounds in coffee itself, regardless of caffeine, may potentially have an appetite suppressing effect. Now, it could be because of those bitter compounds. Other healthy bitter foods or beverages that have the potential to activate those satiety sensors in the NTS include cruciferous vegetables like kale, broccoli, Brussels sprouts, arugula, radishes, and orange or lemon peel zest, which contain the compound limonene, which is a very strong bitter tastant, and unsweetened green or black tea. Now, we do not want to add sweeteners, as you'll notice I said unsweetened, to these items because a sweetener would negate the whole purpose, which is to activate the satiety neurons of the brain without strongly recruiting the brain reward regions. For example, someone had asked me when I did my initial episode on bitter tastants, they asked me about tonic water. But you see, tonic water has sugar in it, so this would not be a good option. So bitter tasting drinks and foods may recruit our satiety brain regions and therefore could induce that satiety response, potentially help reduce food cravings. So what else could activate our satiety brain regions without being addictive? Interestingly, organic acids can. As I mentioned before, sour and bitter taste have a similar effect on the NTS satiety brain region. Giza and Scott are pioneers in this area of taste and the NTS brain region. They published many studies showing that bitter tastes and sour tastes can recruit the NTS. So what does this mean for our strategies? Well, for example, I spoke about apple cider vinegar in episode 8. Surprisingly, this episode remains to be the #1 listened to episode of all my 58 published episodes. In episode 8, I go into the details of clinical trials looking at how small amounts of apple cider vinegar, ranging from 2 teaspoons to 4 tablespoons a day, can potentially reduce blood sugar levels in those living with diabetes. And more importantly, for today's episode, how apple cider vinegar can induce satiety and reduce appetite. For example, Darcy and colleagues published in 2011 that vinegar may reduce appetite and induce feelings of fullness and satiety because acetic acid, present in vinegar, is a short-chain fatty acid that may act upon the short-chain fatty acid activated G protein coupled receptors that can release leptin and neuropeptide YY, which are known to induce satiety and reduce appetite and food craving. Darcy in 2014 investigated the effects of vinegar on measures of appetite, satiety, or feelings of fullness, as well as the tolerability of ingesting vinegar daily. Ostman in 2005 and Mettler in 2009 share the same findings. The investigators all noted that ingestion of vinegar does indeed reduce appetite and induce measures of satiety. But the scientists warn that vinegar ingestion may induce feelings of nausea, and thus to be very cautious of this. This brings me back to the concept that this brain region, the NTS, can also induce aversive feelings, which I talked about earlier in the episode. Remember that sliding scale of feeling satiated and then going too far and then having the aversive negative effects? So if any of these satiating items are consumed too much, aversive or negative feelings can happen. So please do be careful with acids like vinegar. I do not want people to go now thinking that they can drink vinegar. That's not what I'm saying. These clinical trials look at very small amounts of vinegar with 5% acetic acid that is diluted in a glass of water or added to food. So for example, they added 2 teaspoons of apple cider vinegar to a glass of water, or they made a vinaigrette out of the apple cider vinegar and added it to vegetables. Consuming vinegar straight can have very harsh effects on our teeth, our throat, and our esophagus, so please keep this in mind. Another thing that can activate the NTS without recruiting the brain reward pathway strongly is mechanical distension of the stomach. In simple terms, a full stomach. A full stomach sends a signal via the vagus nerve to the NTS brain region to induce a satiety response as well. So we can achieve this in a healthy manner by consuming the daily recommended amount of vegetables per day. The US government recommends eating 2.5 cups of vegetables per day, and the Canadian government says to consume more at 7 to 10 servings of vegetables and fruit per day, where 1 serving is half a cup of vegetables, or if it's green leafy vegetables, then 1 cup of vegetables equates to a serving. So vegetables are bulky, and they increase the mechanical distension of the stomach, and vegetables themselves at the same time are not addictive. Again, don't add sweeteners or simple carbohydrates like potatoes, rice, white bread, white pasta, sauces with sugar, etc., as these may cancel out the effects, right? We want the satiety sensing neurons to be activated, but not necessarily the brain reward pathway, because we don't want something to be addictive. So the ways to induce the NTS and satiety response include bitter foods and beverages, sour taste like from vinegar, which may also contain short-chain fatty acids to induce gut satiety hormones, and eating bulky, healthy foods like vegetables. These are all strategies that could, in a healthy way, induce that satiety response by recruiting the NTS. Now, I do have to say that food craving is a very complex situation that involves many other brain regions and systems in our body as well. For example, I also want you to listen to episode 1 if you haven't yet, as I talk about another brain region involved called the lateral habenula, and how this brain region is involved in the disappointment of not receiving an expected or pleasurable item, and the negative mood that is associated with not receiving that reward. So for example, if you're used to sitting in front of the TV on the couch at 7 p.m. and eating a bunch of junk food, and then you try to eliminate the junk food from your diet and you're sitting in front of your TV on the couch at 7 p.m., your brain is expecting that reward. But if you're not getting that reward, in animal studies anyway, we show that the lateral habenula is activated, and that contributes to the negative mood and the propensity for a relapse. So I go into detail on how to avoid the lateral habenula from being activated, and I think it is a great supplement to today's episode. So consider going back to episode 1 to give it a listen if you haven't yet. So that is a wrap, my people scientist army. I think there's a lot of power in understanding why we may feel the way we do. There is power in knowing our own brain and how it is being affected during certain things. Now, the next time we eat something delicious, rich in sugar and fat, we can think to ourselves, I know my brain reward pathway is being recruited, and that is why I feel good eating this. Then, I know my NTS is being recruited, and that is why I feel satiated and satisfied. But then when you are trying your best to avoid unhealthy junk food and instead try to follow a healthy diet, you can think, my brain reward pathway and NTS are not being activated the same way because I'm not eating junk food. That is why I have these food cravings and maybe a lower mood right now. So what can I do to activate these brain regions in a healthy way? Well, I can exercise, I can listen to good music, I could take a hot shower, I could talk with my friends on the phone, I can eat 2.5 cups of vegetables, I can drink some decaffeinated coffee, or I can add a small amount like 2 teaspoons of apple cider vinegar to my water. These are all possible suggestions on how we can empower ourselves with the knowledge we now have of our brain and how to hack our way out of unhealthy food cravings. Now that we understand the neurobiology of food craving, we can generate new strategies. As always, seek the advice of your physician or dietitian before making any changes to your routine. I'm simply just sharing some neuroscience and nutrition information, some food for thought. If you have any questions, please feel free to reach out to me on social media. And make sure to follow me on social media if you don't already, as I like to share tidbits of information and some fun videos on the week's topic. I'm most active on Instagram if you have the choice among social media platforms. My handles will be in the description box to this episode. Now remember, there is power in knowing why we feel the way we do. I hope you all have a super healthy week, and I look forward to meeting you back here, the same time and the same place next week on the People Scientist podcast. Bye for now.
I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.